Hello everybody, good morning or good afternoon. I'm Luc from NKE Instrumentation. First, I'd like to thank you very much to be more and more people to be present to our Flash webinar. So this is our second webinar session. So for those who were not present to the first Flash webinar session, the concept of our Flash webinar is a short-term webinar. We try to keep it into a 15-minute session. And there is no PowerPoint. The only time you will see my computer screen will be when I will show you the interface of the product. So we try to keep it as dynamic as possible and also to show you how much things on the product that you can see through the camera. So it will go through a 15 minutes presentation. If you have any question, you can type it into the question field throughout the presentation. And after, we will take some minutes if you have questions to answer them. So today's topic is about the WiMo sondes. So some of you may be or may not be familiar with our previous range of multiparameter sondes. So the WiMo is the full new multiparameter sondes that we are manufacturing. What I will do is I will first present you the general specificities of the WiMo sondes and the main accessories. Then I will go through the interface, so I will connect in real time to the sonde and show you some of the main features on the interface. And then we will try to go through example of application using the WiMo sondes and using its modularity. And it will be also actually the opportunity to show you for the very first time some of our new accessories that will be proposed to the market soon, especially the communication module. Okay. So let's start with the WiMo. So WiMo stands for two things. Y stands for Wi-Fi, which is the way that the WiMo can communicate on a point-to-point range, and then you can access the embedded interface without installing any software. Then Mo stands for Modbus, because the WiMo, through a subcon connector on the back, can receive power and also communicate through Modbus, and it has a user selectable serial link. So it can be whether RS232 and RS485 without any modification. So it's a totally modular. You can select in the interface whether it's RS232 or RS485. So WiMo stands for this, Wi-Fi and Modbus. So you have two versions of the WiMo. This one is the first version, WiMo, with 4 inputs. And there is also the WiMo Plus that I will show you afterwards, which has 7 inputs. So what is interesting already is that each input can accept separately any type of weather sensor or weather anti-fouling system, such as the wiper. You can put them in any location, and it is automatically detected by the sonde. There is no prior or post action to do. Here, you can put the sensor guard that is just screwed on the sonde. So the holes that you see on the top are to have the best measurement with the optical sensors, and the holes that you see on the bottom are just to remove the airflow when we are putting the sensor guard. So as you can see, when I have my sensor guard on, I have a fully solidary system. On the back, you can whether add them or remove them. We have handles, which are ideal to make some profiling. Actually, also, these 2 screws can be used for other type of implementation that I will show you afterwards. Please note that these are not plastic, but this is metallic handles, which make it pretty rugged and tough. And the main material of the WiMo is a POM material, which allow the WiMo to be deployed down to 250 meters depth. So I'm just going to show you the WiMo Plus. So this is the WiMo Plus, where I have Here in that case, I have 5 parameters and the wiper brush in the middle. If it's a WiMo 4, I just put my wiper somewhere on the side, but in the WiMo Plus, the wiper is always in the middle. Here I have my city sensor, I have different fluorimeters, I have my turbidity sensor. And embedded, the WiMo already has a pressure sensor. So it can already be pressure measuring instrument, so it's embedded inside the WiMo, and then you add the other parameters. One of the big difference also on the WiMo compared to our previous range lays on the digital sensor. I will show you. Most of the brain is actually inside the digital sensors. The digital sensors are real plug-and-play sensors. We have designed our own connection type with coded pin in order to ensure the 250 meters depth ratio. Each sensor stores its calibration inside, what means that you can actually calibrate separately the sensor from the sonde. And this is pretty interesting. You don't need the sonde in order to calibrate the sensor. As an example, this is a tool that we are finalizing in order to directly make calibration of the sensor with a computer. So what I'm going to do now is showing you how you can access to the interface of the sonde, going through general features of the sonde. And what I will do is I will connect the sensor so that you will see the real-time detection of the sensors and what you can do with these. And afterwards, we will go through example of different applications. So what I have here with me is a tool that is always provided with the WiMo. First, you have this tool, which is a magnet stick. So actually, it's a magnet inside that I will place close to the sonde for 2-3 seconds, and then it will activate the Wi-Fi of the WiMo that will remain on for several minutes. Then what you see here is a tool to help the opening and the closing of the sensors. Actually, this is optional tool. You will see I will manipulate the sensors with my hand, but if necessary, you can have this tool in order to help the opening and the closure. So now I will go close to the Wi-Fi signal that you see here, and I will place the magnet here. So now the Wi-Fi of the WiMo is on. So here you can see on my screen, I can see here that I have my WiMo that appeared as if it was an internet box, and I'm connecting to it. And then I'm typing here the IP address of the WiMo. So actually, it automatically refreshed. So now I am on the WiMo interface. So here you can see the main dashboard when I can have my general information about serial number, battery capacity, time, so I can put the time, the memory, the standard formats, as you can see, standard CSV. I can also choose whether or not to zip the files. And here is, for the Modbus part, you can see on the bottom, so WiMo stands for Modbus. Here you can select whether to enable or enable the Modbus, and you can select also whether it's RS-232 and RS-485. So you can see it's a very modern and easy to use interface. On this side, I have information on my parameters.
What is very important here on the main page is that you see a drawing. We wanted this drawing to be a general understanding, just a single look, and I know what's going on with my sonde. Here on the left, I see that Modbus is deactivated. I see that I have no mission program, and I have only the pressure temperature embedded sensor that is here. And if it's colored, it means that I decided to store its data. I'm showing you. If I deactivate my sensor, so I still have my sensor, but I don't want to store the data, then it becomes gray. Same thing for the Modbus. I have the Modbus capacity. If I activate Modbus, then Modbus appears here in orange on the left-hand side of the WiMo. There are also other tabs. One is the measurement file. So you can see here it's standard CSV file. You just click and download. It goes into Excel. Then here you have a real-time measurement, but of course here I have no sensor, so nothing can go on. And here it's a specific table called alarm dedicated to help us for the response of the probe for long-term deployment. Typically, did something block the wiper? Did something is going wrong? Do I have low battery, etc.? So you can select whether or not to log the key alarm information, and this is more dedicated to long-term deployment with the transmission module that I will show you afterwards. So what I will show you here, so here you can see on the right-hand side where it says available parameters and connected accessory. What I will do, you can see on my little video window, I hope, is I will connect two things. I will connect a turbidity sensor and I will connect a wiper brush. So here I just use the coded pin, connect my sensor. I hope you can see my video. I want to show you one thing that is important when we talk about robustness of the sonde. Well, don't do this all the time, but this is pretty rugged. So there is no movement and the connector remains perfectly stable. So here I connected my turbidity sensor. The only action I will do in the interface is click on the update button here, refresh sensor connected. And then you see that the turbidity sensor just appeared. So I have my turbidity sensor, I have the general information, and I can click here to see the calibration that is inside the sensor. What is interesting also is some of the sensor has the capability to calculate parameters. For example, the CT sensor would be able to derive total dissolved solid, sound velocity, salinity. So you can select also whether you want to store the measured data and also calculate derived data. And now I will just connect the wiper. So the wiper is also a digital and smart wiper, which means that the wiper detects which sensor it has to clean. So here, once again, I will refresh my sensor and accessories. And on this accessory part, you can see that the wiper appeared. I can select whether to use it or not, and I can choose the periodicity. And here, I can make a quick working test. And you see, it detects the sensor on this side. So it knows where is the sensor it has to clean, and it's cleaning it. Finally, here, you can see the acquisition settings. So the WiMo has many different flexible settings, especially in the term of start and stop modes. So there are 3 start and stop modes. One is manual. So click and start and stop with the sonde. One is a date. So it's a typical schedule. And one is a condition. So the condition start and stop mode is from any type of sensor, which makes it very interesting, especially if you want to monitor a specific moment or use this for a dedicated type of deployment. For example, I want my WiMo to store at a high frequency only if the turbidity is higher than a certain level. Or, for example, I want to store data only if my sonde is inside salt water or even inside the water. And the same thing for the stop mode. So this means that you can whether use the sonde on a long-term basis regular, or you can use these specificities to optimize the battery and the storage capacity. Okay, so now we're going to go through different examples of application of use of the WiMo sondes. So I will try to go through general topics. The first one will be the one using start and stop modes, and I would say point-to-point measurements. Then the second one will be more focused on example of long-term measurements. So point-to-point measurements generally will ask to two types of programming mode of the sonde. Whether it's a manual mode, so you go in the interface, you click on start, you deploy the sonde, and you recover your sonde afterwards, and you click on stop. Or you can use a pressure condition. Typically, a pressure condition can be ideal if you are on the field and you don't want to manipulate any element. You just have your sonde on a rope, and what you do is you will determine two depths. This is my water. And you will say, I want the sonde to start to measure when I reach this depth, and I want the sonde to stop measuring when I reach this higher depth. So the sonde is in the water, reaching the depth, making the profile, coming up, storing the data, and waiting again for the next condition to start and stop. So this could be a pressure condition, but actually also it could be a conductivity condition. For example, if you're in salt water, so just when it's in the water, it will start recording, and it will stop when it will be out of the water. So this can be an interesting solution if you have people going on the field who do not know at all how to use or how to manipulate an instrument. It's a zero training mode of use. But actually also this can be interesting for not a human, but also can be used for any type of carrier. For example, I have a small USV with a winch and the WiMo here. So in that case, you can move from place to place with the USV and just start the winch. So there is no cable, electrical carrier cable on the winch, so it can be a very light winch. You just deploy the sonde, it starts automatically any measurement, and then let it come out and it stores the data. Then I told you it would be the opportunity to show you some of the first, for the first time, some of the new accessories and features we are launching on the market with the WiMo sonde. And one of the main ones is the communication box. So this is a communication box. On this side, you have a subcon connector that can go directly to the sonde. Inside this, I can have internal batteries. So it can last several months, transmitting, say, single time per day or per week or etc. Inside this, I have two things: GPS position and a dual SIM GSM. So actually, what is very interesting is without requiring any automat, any big solution, you can have a full real-time monitoring system combining a WiMo sonde to this module. This is directly programmable inside the sonde interface. So you can directly program how long and how often you want to transmit the data, together with how often you want to measure the data. So you can totally separate the frequency of the measurement of the WiMo and the frequency of transmission of this module. And what is very interesting is that both the WiMo and the transmission module are only powered on their own alkaline batteries. So the transmission module will use its own alkaline batteries, and the WiMo will use its own alkaline batteries. And you can have a month-long or year-long monitoring stations, depending on the fouling, of course, only based on alkaline batteries on these two modules. Also, this is also a rugged material, so it means that it can resist to any type of condition. You could actually put this under the water also. And from this, it can ease you the way to make real-time measurement, especially for coastal, for pontoon, etc. Some example I have here. We make different type of coastal monitoring buoys. You can make some pontoon measurement this way. Yep. This. And you can also have some coastal buoys. Like this one, I have a real one with me, so you can appreciate the size. So what is very interesting is, as long as I have something that does not require any automat, any other tools, then I can put it a bit everywhere in a smaller compact system and pretty resilient. So just so that you can appreciate the size and how the concept, I will just briefly show you a float. We might have dedicated flash webinar on the float, on the real-time applications. So I'll just briefly show you. Here with me, this is my float. So I have my float, and actually here I have a fill tube. And inside this tube, I can have this type of stake. So here I have my WiMo that is at the end of the stake. It's this way. And what is very interesting is that I can extract the stake without removing the float from the water. And finally, WiMo. Sorry for this one. And finally, the WiMo is Modbus capable, as you have seen, but also we have made a specific WiMo communication mode, which is called TopCAPI, which is a specific way and data format that is fitting to enter into the big servers, especially in the freshwater application. So what you have to remember about the WiMo is the fact that you can have with a single tool a very high flexibility of use. You can use it for point-to-point measurement. You can use the very same sonde with no modification inside the float. You can add a communication module, or you can connect it to a bigger automat and make the WiMo just a Modbus element of a bigger buoy or a bigger infrastructure. So that's it for the WiMo introduction. I hope you appreciated this very first flash webinar. I saw we have 1 or 2 questions here, so I will try to answer them just now. Thank you. Okay. Alors, WiMo is why you cannot real-time reading. WiMo is a wave by itself. Why it cannot real-time reading without sensor? Could you tell me the position of the vessel? Yes. So actually, it can measure, it's true, like the WiMo without any sensor can be a WiMo wave. So if you remove the sensor, we can measure pressure and temperature up to 16 Hertz velocity and make specific burst acquisition for the wave mode. This might be also showed a little bit further in a specific topic that will be about marine submergence, but this is actually true. And actually, the pressure and temperature sensor, I don't know if you can see the little hole in the middle. So this is where the pressure sensor is positioned. And with regard to the question of what is the frequency of checking the condition, actually the frequency of checking the start and stop condition is user selectable. So in the interface, there is something called the monitoring period, and this monitoring period refers to how often I want to check the condition is true. So actually, it's totally free from 1 second to hours or days on this frequency checking condition. I think that's it for the questions. What about biofouling? Okay, that's a good one. So biofouling, we have two main type of sensors. One of them would be optical sensors, and the other one is a CT sensor. So I would just start by the CT sensor first, because it's one that cannot be easily cleaned by a wiper. So this CT sensor has, like the Y-Sense range, actually the exact same copper alloy protective cage. So what is interesting is first, this copper alloy cage does not damage the data measurement because it does not lose any particles, so it does not impact the data. It does two things. First, it protects the sensors, really protects it. And the second thing is that it protects from biofouling as it's copper-based, and it's a removable cage. So it means that for maintenance, you remove the copper cage and you can clean the sensor, the CT sensor. So you can see here, conductivity and temperature cells. You remove this, you can clean this with a metallic brush, and then you will clean this CT cell with fresh water. And then for the other ones, the optical sensors are cleaned by the digital wiper. So the wiper on a determined sequence will be cleaning the optical sensor to optimize fouling. And with regard to the question of how long the instrument can stay without cleaning, this is extremely depending on many parameters. What type of area is it? What type of water? Is it brackish water, salt water? What is the temperature of the water? What is the intensity of the fouling in the area? So in that case, the duration can be more or less long. Also, what period of the year? So typically, if we are in Europe and in winter, you do not require to go very often to clean the probe. Whether that if you are in summer, maybe a month or 2 months, not to clean the sensor, but also to clean the external part of the sonde might be necessary. But generally, the sensor remain clean. I try to answer them in the good order. What is the frequency for calibration? Also, this depends on many parameters. Typically, the optical sensors, optical-based sensors, turbidity, the fluorimeters, do not require a calibration very often. They just need a point-to-point measurement. We still advise a yearly calibration if you want to be sure. The most sensitive ones would be the conductivity, that for sure requires a yearly calibration, and pH and RP sensor that you all know in this field are the most sensitive ones. So that one might require whether an often calibration and also might require replacement, especially if they are deployed continuously in the field with a lot of fouling. So typically a pH sensor, you might need to replace it every 6 months, say, for example. But this is really depending also on the parameters. Okay, I just saw the precision of Cédric Jamet, who is saying English channel provided marine very to bit high tides. Okay, yeah, this is not an issue. The wiper is really designed for this application. So actually, the more problematic area would be an area with a very high temperature, rather than turbidity. Turbidity can be solved with the wiper, so it's not a big issue. You might need to go more often if you are in a very hot waters, like what you can find in Asia, for example. Okay. Vas-y, on va voir. Ouais. Okay, frequency acquisition. Okay, alors, I will answer to the one with the frequency acquisition and the plan to the additional sensors. So, acquisition frequency of the sensor is about 1 Hertz, as far as I know, and except if you remove the sensor, as I say, and I use the WiMo just for the pressure, I can have a higher frequency, but the frequency starts in about 1 Hertz, and then you can go in lower rates. Might be 2 Hertz with some of the sensors. The optical sensors might take a little bit more time to stabilize the measurement. Then with regards to the plan to extend the fluorescence probe types?
In the limitation of what I can say, yes. Actually, at NK Instrumentation, WiMo sonde is really one of the main focus of our R&D department, which is actually just here. You cannot see it, but our engineers, still respecting the COVID, are working hard. And yes, every month, every 2 months, or every week, I don't have the pace, but more sensors will come. So really what we wanted to have is the central element, which is the WiMo sonde, which is really a platform accepting any type of sensor, and be able to improve the number of elements that we will measure, both measure and calculate. So crude oil is part of it, definitely. Yeah, tryptophan should be. So WiMo is 250 meters depth rated, including all the elements, wiper and sensors. And actually, we're making some tests, and maybe in a moment, I hope we will be able to tell you we can go deeper. But this is a real, at least 250 meters. Okay. Good. So I'd like to thank you very much again for your present participation and the very nice interaction and questions. Of course, if you have more questions, you can whether send us an email, or if you are very, very willing to see a little bit again and more questions, you can come again to the same webinar this afternoon. And if you have a question that just popped in, just join the webinar during it, add the question, so I will try to answer it this afternoon. Thank you very much, and hope I will see you to another Flash webinar. Bye-bye.